We have question number 51, which says that the mass of 80% pure H2SO4 required to neutralize 106 gram of sodium carbonate S. So first of all, write the reaction between sodium carbonate and sulfuric acid. So we have sodium carbonate plus sulfuric acid. So the products will be equal to Na2SO4 plus H2O plus CO2. So now you can see here the 1 mole of sodium carbonate is reacting with 1 mole of H2SO4. So 1 mole of sodium carbonate means 106 gram, as the molar mass of sodium carbonate is 106 and the molar mass of H2SO4, that is 98 gram. But it is for 100% pure sample. So for neutralization of 106 gram, the 98 gram of H2SO4, that is 100% pure, is required. But we have to calculate now for 80% pure H2SO4. So for 80% pure H2SO4, how much mass will be required? It will be equal to 100 divided by 80 into 98. So if you calculate this, the answer will come out to be 122.5 grams. So option number 2 is our correct answer. So moving on to the next one, we have question number 52, which says that the 100 ml of propane gas undergoes combustion with 100 ml of oxygen. The total volume of the reaction mixture after the combustion is. So write the reaction between propane gas with oxygen. So the propane gas is C3H8, which is undergoing combustion. So the products will be carbon dioxide and water. So first of all, balance this equation. Here it will be 3 and here it will be 4. So total oxygen are 10. So this is our balanced chemical equation. So you can see here, for 1 ml of propane gas, we will be needing 5 ml of oxygen gas. Now you have been given 100 ml of propane gas with 100 ml of oxygen. So जब 1 ml of propane gas के लिए we are needing 5 ml of oxygen. So 100 ml के लिए required volume of oxygen will be 500 ml. But here only 100 ml is given. So it is my limiting reagent because it is present in lesser amount. So it is limiting reagent. So now you can calculate how much volume of CO2 is produced. So from 5 ml of oxygen, 3 ml of carbon dioxide is produced. So from 100 ml of oxygen, how much volume of carbon dioxide will be produced? It will be 3 divided by 5 into 100. So it is equal to 60 ml. So here I have calculated only the volume of carbon dioxide, not the volume of water, because at STP, carbon dioxide will remain in the gaseous form, but water will remain in the form of liquid. So we will not calculate the volume of water. So now also calculate the volume of propane gas left. So you can see here, from 5 ml of O2, 1 ml of propane gas is reacting. So with 100 ml of O2, how much volume of propane gas will be reacting? It will be equal to 1 divided by 5 into 100. So it is 20 ml. So 20 ml तो react कर गया, तो बचा कितना? 80 ml. So volume of C3H8 left, it will be equal to 100 minus 20, that is 80 ml. So now we have in the reaction mixture 80 ml of propane gas and 60 ml of CO2. So the total volume will be equal to 80 plus 60. So it is equal to 140 ml. So the option number 3 is the correct answer. So moving on to the next one, students, we have question number 53, which says that the percentage of p character in hybrid orbital of p4 molecule is. So p4 molecule is a highly strained molecule. So the structure of p4 molecule is like this. So you can see here one phosphorus atom, it is forming 3 sigma bonds and one lone pair is also present. So we have 3 sigma bonds plus 1 lone pair. So the hybridization of phosphorus atom will be sp3. Now you have to calculate the percentage p character. Percentage p character is 3 by 4 into 100. So it is equal to 75%. So the only catch in this question was to calculate the hybridization of p4 molecule, and you can easily calculate then the percentage p character. So option number 2 is the correct answer. So moving on to the next one, we have question number 54, which says that the correct order of oxygen-oxygen bond length is. So we have O2 molecule, and we have O3 molecule, and we have O2 2 negative. So in the O2 molecule, you know that the bond order is equal to 2. O3 molecule is a resonance hybrid, so bond order lies in between 1 and 2. So bond order is equal to 1.5. And in O2 2 negative, the bond order is equal to 1. So higher the bond order, lesser will be the bond length. So the bond order is inversely proportional to bond length. So highest bond length will be of O2 2 negative, followed by O3 and followed by O2. So the option number 3 is the correct answer. So moving on to the next one, we have question number 55, which is related to the dipole moment. So it says that the observed dipole moment of AB is 1.2 dBi and bond length is 1.2 angstrom, then the percentage of ionic character is. So you have been given here the bond length of the molecule AB, which is equal to 1.2 angstrom. So convert this into meters, it will be equal to 1.2 into 10 raised to the power minus 10 meters. So now you can calculate the dipole moment, that is mu, so which is equal to Q into D. So Q is the charge, which is equal to 1.6 into 10 raised to the power minus 19 coulomb, and D is the bond length, which is 1.2 into 10 raised to the power minus 10 meters. So it is equal to 1.92 into 10 raised to the power minus 29 coulomb meter. So now convert this into dBi. So as 1 dBi is equal to 3.33 into 10 raised to the power minus 30 coulomb meters. So you can easily convert this into dBi. So it is equal to 1.92 into 10 raised to the power minus 29 divided by 3.33 into 10 raised to the power minus 30. So it is equal to 5.76 dBi. So we have calculated the dipole moment, that is 5.76, but the observed dipole moment is only 1.2 dBi. So the percentage ionic character will be equal to mu observed divided by mu calculated. So mu observed is 1.2 and the mu calculated, that is 5.76 into 100. So we calculate this, it will come out to be 20.8%. So option number 1 is the correct answer. So moving on to the next one,